This video will introduce you to the first 3 exponent rules that are related in the book on pages 304 to 306. We're going to do this in 2 sections. We'll do the first set of rules, and then later on I'll teach you the next set of rules. We're going to start with the first rule, and what we're going to do is we're going to talk about product of powers by looking at examples. And then I want you to think about the pattern that you see as we look at examples so we can come up with a rule. So number 1a, we have 2 to the 10th power times 2 to the 3rd power equals 2 to the power of y. And you can read and follow along on page 304. So 2 to the 10th power has a base of 2, and it has an exponent of 10. We also call this a power. So just to review what you already know about exponents and bases and working with exponents. The base tells us what we're going to write over and over again, and the exponent tells us how many times we're going to write that value. So the 2 is going to be written 10 times. So it's written 10 times, and we have a multiplication sign in between those values. So this is a product. Now that is being multiplied by 2 to the power of 3. So the base in this case again is 2, and the number of times that we write that base is 3 times. You will see in total that we have the base of 2 written 13 times. So y is equal to 13. In B, the base of 5 is written twice, and then it's multiplied by 5 to the 4th. In 5 to the 4th, the base of 5 is written 4 times. And in total, we have the base of 5 written 6 times. So this is 5 to the 6th. Y is equal to 6. In C, we have 3 to the power of 1. So we have 1 base of 3, and then we have the base of 3 written 7 times. In total, the base of 3 is written 8 times, so y is equal to 8. In D, now we have a variable here instead of at the end. So we write out 2 to the power of w is being multiplied by the base of 2 written out 4 times, and that is equivalent to 2 to the 7th. So the 2 is being written out 7 times. 1, 2, 3, 4, 5, 6, 7. So over here, we have 2 to the 4th power, and I'm going to show you where that is over here. And these are equivalent. So really, 2 to the power of w needs to be equivalent to this piece. So 2 to the power of w is equivalent to 2 to the power of 3. So w is equal to 3. In E, we write out the base of b 4 times. So this works just the same as if you were working with a number as a base. Here we just have a variable for the base. And in total, we have it written out the base b 6 times, so y is equal to 6. In this case, there are a lot of different options for w and for x. All that we need is for the base of 9 to be written out 5 times. So we could have w equal 3, and then we could have x equal 2. Or we could do it the opposite way. We could have w equal 2 and x equal 3. In addition, we could do different combinations. We could have w equal 4 and x equal 1, and vice versa. We could also have 9 to the power of 0 times 9 to the power of 5. We could go into negative numbers and we could say, well, we could have 9 to the power of negative 1 times 9 to the power of 6. So there are really endless options. The total just has to be 5. And now what I want you to do is I want you to pause the video and think about what the pattern is in all of these situations. What do you see happening over and over again? What has to be true for you to follow the rules that you're coming up with? Okay, hopefully you paused the video and you had time to think about it. B to the power of n, m times b to the power of n would be equivalent to b to the power of m plus n. Every time we added m and n to get the final exponent. And the other key piece to this is that the base had to be the same. In every single one of these examples, the bases were the same, so we were able to add up the exponents. It wouldn't work if the bases were not the same. So this is rule 1. This is the pattern that we see. And now we're going to look at some common mistakes that people make when they're trying to apply rule number 1. So every single one of these is incorrect that we're looking at. So 3a, 3 to the power of 5 is equal to 15. 3 to the power of 5 does not equal 15. And the reason is this: 3 to the power of 5 really is 3 times 3 times 3 times 3 times 3. And if you multiply 3 times 3 times 3 times 3 times 3, you're going to get 243. So a much larger number. I think that why people get confused when it comes to exponents is that they've just so many times they've dealt with normal multiplication. 3 times 5 equals 15. So when they see 3 to the 5th power, if they don't really think, they just automatically do what they've always done and they say, oh, I see two numbers, I'm going to multiply them, 3 times 5, I get 15. But it's important that you think about how we have 3 times 3 times 3 times 3 times 3. It's not the same as 3 times 5. I think this often happens because the operation that is going on in between these bases is multiplication. We are multiplying. It's just a different idea when you have an exponent. So be careful of that. It's a mistake that I think we'll all make a few times. Everyone in class probably will. But be watchful for it so that you can practice and get better at right away thinking about what you're doing and not making that mistake. All right, number 3b, 3 to the 4th times 5 to the 2nd. 3 to the 4th is really 3 times 3 times 3 times 3. 5 to the 2nd we write out as 5 times 5, and then that is not the same as taking 15 and writing it out 8 times and multiplying it. Okay, those are not equivalent. The problem here is that the bases are not the same, and they're trying to apply rule 1. And what they did is they just multiplied, and they got 15. And then, on top of that, they didn't add the exponents, they multiplied them to get 8. So this one is really incorrect. In C, when we look at this, 3 to the 4th power times 5 to the 2nd power equals 15 to the 6th power. Here, they were getting more at the rule when they went ahead and added the 4 and the 2, but we still have an issue. This is not correct because the base is not the same. So you can't follow the rule where you add the exponents when the bases are not the same. In D, we have 3 to the 4th plus 3 to the 2nd equals 3 to the 6th. Multiplying 3 to the 4th times 3 to the 2nd will give you 3 to the 6th, but adding will not. You have to keep in mind when we're using all of these rules, these exponent rules, the rules are over multiplication and division. When you get into adding and subtracting, you need to think about like terms, and it's a totally different ball game. So 3 to the 6th power equals 729. And then when you take 3 to the 4th power, you get 81. 3 to the 2nd power is 9. So 90 is not equal to 729. Okay, and there's not any more time in this video, so I will go over Rule 2 in the next video.